This is an orthokeratology case where the patient's getting some halos in the right eye and undercorrection in the left eye. You can see that the lenses are shifting upward a little bit, more so in the left. Pretty good central flattening, so I don't think we need to change the power of the lens too much. I think if we center this a little bit better, get more of this plus outside of the pupil, the patient will probably appreciate more of the minus correction that's coming out of the treatment. Um, if I bring up the lens for both eyes, you can see the patient's about a minus 475. And with this refractive error, it's pretty much a guarantee the patient will get some halos. I don't think we'll be able to do anything that gets rid of the halos completely, but we can do a few things to make it a little bit better. One thing I would do first is to make the lens a little bit bigger. I'm measuring about almost 11.5 corneal diameter here, and we're working with a 10.6 lens. So we can go anywhere from probably an 11 to, I wouldn't go past 11.3, so why don't we just go to an 11. So let me see where your zones are first, 6.2 and 6.8. We'll have to change those again after we change this. When we're trying to achieve a slightly larger treatment zone, one way to do that is to move the OZ and IC control points back. But in a lens that's already decentering, I don't like to take away too much material from the periphery of the lens because this is what's going to align everything on the cornea. And the more lens that's available out here for alignment, the more likely we'll get better centration. So a larger lens with a lot more sag should center up a little bit better. Usually with a higher writing lens, we want to increase sagittal depth or steepen the curves on the lens. Okay, we need to reset our center thicknesses. So aside from moving the OZ and IC, another thing we can do is to add some A/C to the lens. And we'll go down here, and we usually like to start at about a plus 20. We'll take note that our demand right now is 5.9 because that will change demands, jumped all the way up to a 7. So let's bring that back down. And we're at 5.9. However, if we go around the different curves, sometimes we see that our power is not very even going our way around. So this is where it gets a little bit tedious. We'll have to go into 25% mode and adjust every meridian individually. So I think our target's going to be around 115 to 120, and they're just trying to make everything a little bit more uniform going around the lens. We're getting closer, but our topo demand's a little bit low now. So we're going to go back and increase this, bring this back to the 5.9. And we just kind of have to go back and forth until our meridians are pretty symmetrical. And this one's a little bit off. Bring that closer. Okay, so we have a lens that's pretty uniform on all meridians. Very similar topo demand to the original since refraction was right about where we wanted it to be. But we should get a little bit more central flattening, and then it doesn't come up again until a little bit behind the pupil. So that should help with getting us a larger central treatment zone, and the improved centration should help a little bit too. So in the left eye, I would do the same changes, increase the diameter of the lens. In this eye, we're a little bit undercorrected, but I think, again, repositioning the lens will help with that. At the same time, I don't think it's a bad idea to maybe add in a quarter more power and also increase the center thickness a little bit. That usually gives us a little bit more treatment. So maybe if you go to like a 22 here and maybe a 24 edge thickness, that usually gives us a little bit more push centrally, and we'll get a little bit more treatment. Same thing, we can add a shape factor to this eye to improve the size of the treatment zone, so hopefully decrease those halos a little bit. So those are my thoughts. Hopefully these help your patient out. Best of luck and thanks for watching.